Hello everyone and welcome to Building Your Own Widget with the ArcGIS JS API. I am JC Franco and I'll be co-presenting with Matt Driscoll. We are both developers in the JS API. We work on widgets and all sorts of UX and UI related stuff. And let's get started. So for today's agenda, we'll be setting up the developer environment with TypeScript and the JavaScript API. And then we're going to be showing you how to create a custom class. And then after that, we're going to go into developing a simple widget. And then finally, we'll combine all this to create our final widget. So in terms of setting up the developer environment, we'll be focusing on setting up the JavaScript API along with TypeScript in the next steps. If you're not familiar with TypeScript, just like its name implies, it's type JavaScript. And what this really means is that with TypeScript, we are able to define the shapes of our objects or functions. And this has a few benefits. One of the main ones is that it'll help you catch errors earlier. For example, TypeScript will complain if I take a look at this snippet here where I'm defining a person with a name and age. And later on, I define one. If I try to assign a string to a property that we know is of type number, TypeScript's going to complain and catch that error. Similarly, if I try to assign a number to a property that doesn't exist, TypeScript catches that. And it's really useful because I don't have to wait until runtime to catch all these errors. And it also helps us keep the code really self-documenting. And what I mean by that is, say I define a greet function with an argument of type person. Later on, if I'm using the function, most of the IDEs now have support to give you some sort of IntelliSense. And in this case, it'll tell me that it's expecting a type person object to be passed to this function. So just by looking at the hints that the IDE gives me, I'm able to kind of learn more about how the API or the different objects or functions that I type. TypeScript allows me to learn them way faster without actually having to create any sort of documentation. Another neat feature is that TypeScript allows us to use JavaScript features that are being added to modern browsers, and we are able to leverage in older browsers because TypeScript will compile into code that older browsers can understand. Here are a few examples of these. There's let and const, which are ways of defining variables and gives you the option of whether you want to allow a variable to change or to stay fixed or constant, like its name implies. Then we have fat arrow functions, which are a very simple way and concise of defining functions. We also have template strings, which are very useful because they allow us to use variables in line in the string itself. So it's very readable and very concise. Another feature is destructuring, which allows you to assign in a single line different parts of an object or different items from an array. So in this example here, from the people array, I am taking the first item or person, and I'm assigning the name and age properties to variables or consts that have the same name, so name and age. Similarly, there is property shorthand, which is a neat way of defining a property if the value has the same name. These are some of the features that you can use that are part of modern browser APIs that will still work in older browsers. TypeScript is also supported on a wide variety of IDEs, so it's very easy for you to jump in and start using TypeScript. So give it a try. For our first demo, we'll be showing how to set up your dev environment to work with the JavaScript API and TypeScript. So let's take a look at my index page, and it's a very simple one, and all that I'm doing is bringing in some CSS, the JS API, along with some configuration, And then I have a div here for a view. And I'm importing my demo application, and we'll get to that in a few, but first let's set up our project. First off, we'll go into the project directory. Then we'll initialize the project with defaults. And all this is doing is it's creating a default package.json with some placeholder values that you can populate later on. And what this means is that we can install TypeScript along with the JavaScript API types. And what this is doing is, by default, TypeScript does not know what the JS API structure of objects or classes looks like. So that's why we need to bring in the types. Once we've done that, we can initialize our TypeScript project. After we do this, the TypeScript compiler is going to create a default tsconfig.json that has all sorts of options here, along with some documentation on what all of these mean. But for our purposes, we are going to use a subset of these that you can find in the TypeScript setup page as part of the JavaScript API's SDK. So we are going to take this configuration and copy it over. And then I'll be running the TypeScript compiler and enable watch mode so that anytime I change a file, it's going to compile the code. So let's go back and take a look at our main application. I've gone ahead and added some code here that I'll start on commenting. As I do that, you can see TypeScript is bringing up some errors because it doesn't know what map is. So let's take care of that import. And once I do that, my IDE can suggest different properties that belong to map. And another neat feature is, say I define a map view, my IDE can suggest the import that I need. So that's pretty cool. And once I do that, same with map, I have access to all the properties that are supported in map view. So as I'm doing that, TypeScript is compiling in the background. And if I check the demo application that I have here, we should see our simple app running with a map. So let's recap. We went through the steps that you need to take to set up TypeScript along with the JavaScript API typings. And then after doing so, we were able to build a very simple mapping application. This wraps up the first part, and with that, I'll hand it off to Matt.
Thanks, Franco. So now I'm going to show you guys how to create a class in our API, and we'll be using this class later as a view model for our widget. So all the classes in our API extend this Esri core accessor class. So this is the API foundation for our API. And what it does is provides a consistent developer experience. For example, let's say I create a class called person, and I have a couple of properties, name and age. I can easily know that I can watch the age property and then call some kind of function. So I don't have to look at the API docs to figure out if there's some kind of event for when an age changes. I know that all the properties in our API can be watched. And setting a property and getting a property is very simple and straightforward. I would just call, me.set age equals whatever. So it provides a really good experience for users. So a little background on what we'll be creating. Here's an ArcGIS online item. And if you'll notice here on the right side, there's a score indicator for how well this item is filled out. And you can see this one has a really high score because it has a lot of content defined. There's things like the metadata that's all filled out. It has like the terms and all kinds of stuff. and you can see more information about how this score is calculated by, this one has a summary, a thumbnail, description, title, tags, etc. So what we'll be doing is creating a widget that does sort of this, but in a little different display. So a little background about what we're going to be creating. We need a class that loads a portal item. It allows editing that item's properties. It will highlight the item's score and provide suggestions on how to improve the score and save an item as well. So that's the requirements for the class we're going to create. So let's look at the item structure. So here's the portal REST API for an item, and you can see some of the properties it has, like an ID, the owner, a bunch of dates, titles, URLs, and down here at the bottom there's one for score completeness, and this gives information about the item score based on what information is filled out. So we'll be using this to kind of drive our class. And then in the JavaScript API, we have a portal item, and this has properties as well. And it has a property to get all of the information from the portal item, and that's where we'll be getting the score. So I think there's a source property, source JSON property, where we can get all that information from. So we'll be using this portal item to load and save any properties that we change. So we'll be working through this through the API. So here's what we want the interface for our class, which we're going to call item score. This is what we need to have in there. So we'll have a property for defining the portal, and if it's not defined, we'll just use the default ArcGIS Inline portal. Then we'll have a property for specifying the item ID. So this will be able to grab the item information using this item ID. Then we'll have a read-only property called suggestions, and this will be determined by the score and what things we can do to improve that score. So when a user sets an item ID and loads it, then it'll calculate the suggestions and the score. Then we'll have a few properties that the user can set and get to update the score, and that'll be things like the title, summary, description, tags, terms of use, and thumbnail. And then we'll have a couple of methods. One will be to load, and this will load the item and all of its information and calculate the score. And then one to save, which will update any of these properties that change back to the portal item. So cool. And so now let's get into the demo. So currently I have this basic class set up, and I have a global variable in the window where I can look at it. And you can see it's extending accessor, but it doesn't have any properties or things set up. Let's look at the code for that. So here's my main TypeScript file. I'm importing an item score. This will be the custom class that I'm going to use. And then I initialize it, and then I store a reference to it in the window so I can access it through the console. And then in my class, it's basically just a simple frame of a class. I'm importing accessor because it's going to extend that. It's importing a few decorators because we're going to define a property, and then we need to declare it here. So we declare it as item score, and it extends accessor. And then we have a few placeholders for where we're going to put our lifecycle methods, any variables, properties, public methods, and private methods. So that's it. So let's start building out this class. So the first thing we're going to want to do is load some dependencies. So we'll import those at the top here. And we know we're going to need a reference to portal because one of our properties is going to be for the portal. So we got to import that, as well as a portal item. And then we'll have some interfaces for the item score properties and suggestions. And then we'll need to define an error at some point if something goes wrong. So we're going to import the Esri core error class. And then we're going to use Esri requests to make any network calls for loading and saving. So now let's add a private variable. And this will be for the item. So once we load the item ID, we can store the item as a private variable, and this will be a portal item type. Then let's start adding some properties. So I'm just going to add all of our properties that we need for this class, and then I'm going to walk through them. So the properties we're going to need are going to be the portal, and by default it's going to use a default portal. Then we're going to create a property for setting the item ID, and this will determine which item to load from the portal. And this will be undefined by default. Then we're going to have a description, and this is going to be an alias property, which means it's just going to point to the item's description, so we can just get a quick reference of it without having to go through the item. And this will be an instance type of portal item description. And then we have another alias property, which instead of having to go through the item's source JSON to get this, we just alias it as score. And this is going to be a read-only property, so user doesn't update this. It's just going to be calculated from the score on the portal item. So read-only score, and this will be a number. Then we have summary, and this is just another alias property. Same with suggestions, and this is going to be read-only and calculated from the item score on what things to improve. So this will be an array of suggestions. Then we have tags, and so this is the tags for the item which a user would set to get a better score. Another alias property. Another alias property, terms of use. So this is the licensing information on the portal item. So a user could set this to get a better score. Thumbnail, which will be a blob type. So the same thing, someone could update this, get a better score for their item. Title, another alias property. User can update, get a better score. So the metadata for the item. Next thing we're going to want to do is set up our constructor. So we go up to our lifecycle methods. Got our constructor, which is just going to take in these item score properties, which we're defining in an interface, which, basically they set the portal and the item ID. And then here's the interface for our suggestions. It's going to have a property and the type, which either is going to be add or enhance it. So now we want to create our public methods. This will be our save and load methods. So we go into our section for public methods. And we're going to create a method to save. So this will save the portal item. If it doesn't exist, if the item is not there, it's going to throw an error. You can't save it. Otherwise, it's going to take the item, convert it to JSON, and update the item. Update the thumbnail if it needs to, and set the suggestions on what needs to be updated still. And then we have our load method, which is going to grab the item ID, but if there isn't one, it's going to throw an error. And then otherwise, it's going to set the item to a new portal item, load that item, and then generate the suggestions based on the content of that item. So you see it doesn't know about these private methods or view item, and so we need to add that. So we'll add this into our private method, review item, and this is going to be like the meat of determining what things to, what suggestions we can do to enhance our item. So we get a reference to all the metadata we want to calculate. We're going to have a list of suggestions, and then if if there's not a summary, we're going to suggest to add a summary. Otherwise, if the word count isn't very high, we're going to suggest to enhance it. And we do that for description as well, tags, thumbnail. If there's not a thumbnail, we should add one. Terms of use, and title. So cool. So I have TypeScript watching a file structure, so it compiles. So this should be updated now. So if we go into this class, and I do item score, I can see that there's no item set, but there is a portal. And if I set an item, I should be able to get these scores and item descriptions and stuff. But you see the properties are there now in the class, so that's good. So what I want to do is I can do item score.load, and it's going to throw an error because we don't have an item ID set. But you can see that the method is working correctly and that error is being defined right. So what I can do to test out this class is I can set an item ID. So item score.item ID equals this string for a portal item. And then I can do item score.load now. And now you see it did a promise and it should have loaded it. So I can do item score, log it out, and now the item is defined and I can see information about that portal item. And it has a description. It's that one I showed. It's the item I showed earlier that had a high score. So you can see that the score is 100. And I can see like the summary, if there's any suggestions. This one doesn't have any because it's got a high score. And then all the information that we were going to have a user set. So cool. So our class is set up now. Let's go back to here. So what do we learn? We learned how to implement this item score class by extending Esri core accessor. We created some properties using the property decorator. We typed constructor arguments, and we created both public and private methods. So now let's talk about writing a widget. So what are widgets? Well, widgets are basically pieces of user interface, and they perform some sort of function or display some sort of information. And they're usually interactive, so a user can click on them or do something with them. And they usually have some kind of state too, so that they're either maybe in a loading state or the user clicked on it and now it's in a different state altogether. So why would you use a widget? Well, you can reuse it in multiple apps or multiple times in the same app. It makes code more modular, so things are kind of bundled and put together. And they help you build more complex apps by using them. So they can interact with each other and makes it easier to create an application. So creating a widget in our API, you would extend the base widget class, which is Esri widgets widget. So this is the base class for creating a widget view. It also extends the Esri core accessor class, so you can watch properties, set properties, and including that, you also get a lifecycle in the widget base class. So here are the main lifecycle methods you get in the class. You get a constructor, where you can define things upon initialization of that widget. There's a post initialize, where you may want to do things after it's been constructed, but before render is called the first time. Then you have the render lifecycle method, and this is where you define your user interface through JSX and virtual DOM. And then destroy, where you can clean up any event handlers or just get rid of anything that you don't need anymore. So render is the meat of the widget. This is where you're going to define your user interface. This reacts to state changes. So any renderable properties that you define will trigger a re-render, and it will efficiently re-render any DOM that needs to be updated. It uses JSX, so you're working with virtual DOM, which is nice. So let's create a simple widget. And this simple widget is just going to render based upon an enabled Boolean property. And that widget will be clickable, so when you click it, it's going to toggle enabled on or off, and the display will change based on that enabled. So this is what it's going to look like. Just a simple button up here. It's either going to be disabled or enabled, and clicking it will toggle its state. Cool. So let's go into that. So here's my simple widget right now. If you look in the top right corner, it just says hello world, and clicking it does nothing. Let's look at the code for this. So going into my simple widget view here, I have my widget, and I have my main, and I have a list of steps to go through. Cool. So here's where I'm creating my map and map view, and I'm importing the simple widget. So I create my map, I create my view, I create my simple widget, and I add it to the top right of the view's user interface. So pretty basic code on what I'm doing to instantiate this widget. In my simple widget, I'm importing the base widget class. I'm importing some widget decorators and decorators for Esri core accessor. So this lets me define a property and declare a class. So I'm creating my simple widget class, and it's going to extend the base widget class. It has a simple constructor, it has no properties yet, and it has a render method that just renders hello world inside a div. So this is what we just saw on the demo I showed. And I'm watching TypeScript for any changes, and it'll recompile. So the first thing we want to do is we want to test out the render method. So let's add a class to this div instead of just saying hello world. So now we have a class of simple widget, still says hello world there. Let's see what that looks like. I reload the page. Okay, so now it's got this big button block look. Cool. Now let's improve it. So we're going to add a property to our widget, and this is going to be our enabled property. And so this property lets me to, as a user, be able to flip this to be enabled false or enabled true, and it's renderable. So anytime it changes, it's going to call the render method again. Let's add some CSS to my div as well. So I've created this CSS map with a couple classes, and I'm using the BEM naming methodology. So this is a block element modifier, and it's just basically a way to name CSS classes to get good specificity on each class. So my base class is going to be the simple widget, and then when it's enabled, it's going to have a modifier for enabled. Cool. So we go back down to our render method, and we're going to update that. So now we're going to get a reference to whether it's enabled or not, and then we're going to render a button instead of a div, and we're going to add the base class, and if it's enabled and enabled is true, we're going to add this enabled class as well. And then if it's enabled, we're going to say enabled, otherwise we're going to say disabled. Cool. So let's compile and test that. So it's disabled right now, and clicking it doesn't do anything. But if I do Simple widget. I'm not sure I have a reference to it, so I'll have to skip that. So let's add an onClick to this. So we add an onClick to our button so that anytime this button is clicked, we're going to call the toggle private method. So we need to add that. And the private toggle method, all it's going to do is flip the enabled status. So if it's enabled, it'll be disabled. And if it's disabled, it'll be enabled. Just toggling the Boolean value of this enabled property. Cool. So now if I reload and I click disabled, it becomes enabled. And if I click enabled, it becomes disabled. So it just toggles it. So really like the simplest widget you can create, but it kind of shows you how renderable properties work and how the VDOM is being updated. Cool. So that's our really, really simple widget we've created. And you can see we did it in less than 70 lines of code. So just to recap that, we created a simple widget by extending Esri widgets widget. We implemented and modified the render method on the widget. We added a renderable property, and that just updated when the property changed. Then we added a onClick event to the VDOM, and that toggled the enabled property. We used a CSS object with the BEM naming methodology. If you want to learn more about that, it's getbem.com, and it just tells you what it is and how to use it basically. And then we toggled the property with the onClick and it re-rendered. So now I'm going to turn it back over to Franco, and he's going to talk about how you can improve our widget.
In this next section, we'll be covering how we can improve our widget, taking the concepts that we learned from building a simple widget and also reusing the logic that we created from the first class that Matt showed how to build. So before doing that, I want to talk about the way we architect widgets in the JavaScript API. And for each widget, there is a view and a view model. And we do it because we want to separate the DOM and business logic concerns. We also want to make it easier to replace the UI if you needed to. By keeping all the business logic in one side, you are able to throw away the view part and recreate one if you wanted to. And this makes it easier to integrate into other application frameworks because you have these two different pieces in separate modules that you can choose to bring in or not. So for views, just like we saw in the simple widget example, end up extending the base widget class and rely heavily on the view model APIs and just focus on UI and DOM aspects. And view models, on the other hand, such as the item score class example, extend accessor, and they provide the APIs or data objects to support the view. So that it knows how to render. And this is where you would keep all the business logic, such as fetching of data or manipulating objects into simpler structures that the view can take and render. The way these two parts work is that the view will end up rendering the state of the view model either through its internal properties or by properties exposed on the view model. Then as the user starts interacting with the view, it'll cause the view model or the view itself to update its internal state. And that causes the view to re-render again and update. And this cycle happens many, many times during the lifespan of a widget. For this last demo, we'll be creating the item score widget to give a face to the item score class that you created with Matt a few steps back. Before doing so, let's just overview some of the changes that we'll be making. For the view model, we'll be taking the item score class, just renaming it so that we know that it is a view model. And then we'll be adding a state property. And this property is going to end up supporting the rendering of the view so that it knows when to render the idle, loading, or ready states. Then for our widget itself, we're just going to expose two properties from the view model. So the portal and the item ID, to keep it really simple. For styling, we'll be using the calcite web framework, which makes it really easy to style some of the parts that I used in my widget with CSS. To summarize the changes that we'll be making, we'll be updating the item score class and making it into a view model, and then add a state property. Then we'll create the item score view, and we'll be aliasing some view model properties, creating a CSS class object using the BEM methodology, and then we'll be rendering different sections of the item. So this demo builds upon the other demos that we've seen, so there's a lot of similarities. The index page is very similar to the ones you've seen before, except that I'm now bringing in the calcite web CSS style sheet. In our main application, I am just creating an item score widget, which doesn't have anything right now. And we'll be passing an item ID property and specifying the container for the div and exposing it into the window if we want to run some tests. So we can start in our view model, and I've gone ahead and already renamed it to item score view model to save a few steps. And the next thing that we want to do is to add a state property like we saw in the slides. So what this does is, based on the status of the portal, if it is loading, the state of this is going to be loading. And if we already have an item, based on its loading status, it's going to be either loading or ready. And if we don't have a portal or item, we're just going to be idle. We are now done with our view model, and we can move on to the view. So if I look into my view file, I don't have anything except that I am extending the widget base class and set up my constructor with the item score properties that I'm expecting. So let's start off by adding properties to our widget. So I've added an item ID property, which will be aliased off of the view model. And same thing for portal, which will be aliased off of the view model as well. And we also define a view model property. And we'll update the widget so that anytime any of these view model properties change, it's going to schedule rendering automatically for us. But first, let's take care of these imports. Next up, let's focus on the rendering. For the next step, we'll be focusing on rendering. And first off, let's add our item loader. And all I'm doing here for my main rendering method is to create a div with a bunch of CSS classes. And I'm also rendering the item loader. And the item loader is where I am able to provide the item ID and kick off the item loading. I have some errors here because of the event handlers that I have not added, so I'll bring those over. For my input, whenever I make changes to it as I'm typing, it's going to call the handle simple value change. And this event handler is reusable because it's using a pattern where I define a property name that belongs to the view model. I'm assigning it to an attribute on that input and then using it to assign that value to the view model. So for example, the data item prop attribute for the input is item ID. So whenever the input fires a change event, it's going to update the view model's item ID property. Whenever I hit the enter key on that input, I've defined the handle input key down handler and listens for the enter key to be pressed, and if so, it's going to kick off the view model's load method. And in the same way for the button, whenever it's clicked, it's going to call the handle item load method, and it's going to call the load method on the view model as well. So similar to Matt's demo, I'm using some convenience objects to store all my CSS classes and my text strings that I've gone ahead and defined in a resources file. So this is where I have all my CSS classes, and some are from Calcite Web. And anything that is text will be stored in this i18n object. So let's go back to my widget and import those objects. Now I can check out my demo. So now I should be able to see my widget rendering and allow me to enter an item ID. And this is loading the item. I can try it out again so you can see. So if I check out the view model state property through my widget, you can see that it starts off as idle. But once I provide an item ID and click load and check the state again, it's ready. So let's continue with our rendering. And next off, we're going to be focusing on adding a loader. And up next, we'll be focusing on a progress bar to show as the item data is being fetched. And I can do that right now by updating our render method. In this version, I will be storing the state of the view model. And whenever that state is loading, I'm going to display the progress bar. Otherwise, I will show nothing. And let's take a look at that progress bar rendering method. And all that this is doing is creating some divs and applying some CSS classes taken from Calcite Web. Now if I reload and enter the item again, we'll see a progress bar whenever I hit enter or whenever I click the load button. For this next step, we'll be rendering the item score after the item is loaded. And let's bring up our updated render method. With this change, in addition to checking for the loading state, I'll also be checking for the ready state. And whenever this is the case, I'll be rendering the score. For my render score method, I'll be displaying the score as well as a score bar. And if there are any suggestions on the view model, we will be rendering the first one. And what this does is it will be grabbing the first suggestion from the view model. And if this is the case, it's going to create a container for my suggestion. And it's going to use the i18n object to grab the appropriate message based on the suggestion's property and the type. If there is no suggestion, I'm not going to render anything. I do have one error here because I have not defined getScoreColor. So I'll copy over the getScoreColor method. And all this is doing is based on a score, it's going to return a different color. So if I reload and load the item again, I will now see the score reflected in the bar here that you see, as well as the first suggestion to improve my item score. And for this next step, we'll be rendering different properties from the item. So let's go ahead and update our render method. And what's different now is that besides rendering the score, I'm also going to be rendering this item form. And what this is, it's going to be a form that displays different properties from the item. So it's going to display the title, the summary, description, tags, terms of use, and a thumbnail. And for each one of these, it's also going to allow us to update the value, either by using an input, text area. Let's continue by adding some variables that this form depends on. And this is going to be used to display a preview for the thumbnail. And let's add other event handlers that we need. So most of the inputs are going to be using the simple value change that we saw earlier on. But for tags, it's going to be slightly different because we're working with space delimited values. So we'll be splitting the value and using that to set the tags on the view model. And for the thumbnail change, since we're using an input of type file, it's going to allow us to select a file and set that as the value for the view model's thumbnail. And we'll also prevent the form's native submit behavior that will prevent the page from reloading. If I load the item again, I'm now able to see different properties from the item. But notice that thumbnail is just displaying in blank. There's no image there, so let's go ahead and fix that. In order to do that, let's add a method that will update the thumbnail blob URL that is being used by the image. So let's go ahead and add that method. And what this method does is that it allows us to take a blob and turn it into a blob URL that can be used inside of that image tag that we showed earlier. Next up, let's actually use this method by leveraging some of the widget's lifecycle methods. So whenever the widget is initialized and a thumbnail is set up on the view model, it's going to update the blob URL for the thumbnail. And whenever it's destroyed, it's going to free that resource. If I load my item again, I should be able to see a thumbnail now. Awesome. Now, if I try to update any of these input fields, it's going to technically store them on the view model, but there's no way to save it to the item. So let's go take care of that. We'll be updating the render item for method and adding a button that will allow us to save. And this button will use an active save variable to toggle its disabled attribute on and off. And we'll also be using an event handler when it's clicked to save the actual item data. Let's go ahead and add those. So for the item save handler, all that it's doing is it is calling the save method on the view model and keeping a reference to the promise. And it's going to store the promise so that the widget will render and update the button that we just saw. And whenever the save promise is resolved, it's going to clear the active save property. So let's go ahead and define that as well. In active save, it's just going to be a reference to a promise. And similar to thumbnail blob URL, it's also going to be renderable. So when this property changes, it's going to re-render. And with that, we are done with our widget. And if we reload and check the item again, we should now see a save button here in the bottom left. And now if I make changes and save, we should see the score improve. And now we get a different suggestion to improve our item. If I make another save, we'll see the score bump up. And now the suggestion will focus on a different property, which is description. And I can keep making changes and we'll see the score move up and up. And that is it. That is our item score widget. To recap, we showed you how you compare a view and its view model and use the view model APIs to render properties on the view. We were able to wire up interactivity by using event handlers in the JSX. And we were also able to apply styles with classes. And we also saw how, based on properties changing, the UI automatically re-renders. To recap the session, we showed you how to set up your dev environment if you want to work with TypeScript and the JS API to create your own widgets. We showed you how you can create a custom class, and then showed you how you can use that class as a view model to power the item score widget. Here are a few additional resources that you can check out in the slides, and I'll provide a link at the end of the presentation. Here are some other sessions that you can check out to learn more about getting started with the JS API, TypeScript, tips and tricks for development and debugging, or if you want to learn a little bit more about customizing widgets. If you have any questions, such as where can you find the slides and source, we have a bit.ly link, bit.ly/builtwidgetsds20 will take you to a repository that hosts the slides as well as the demo code, so you can check that out. And if you have any questions, you can submit them at the following link, bit.ly/askjsapi, which will take you to GeoNet where you can post your question. And with that, we are done. Thank you so much for watching.